Welcome to Science Boosters. In this part 3 of our Big Bang series, we talk about the limitations and the dilemmas around the Big Bang theory. The Big Bang theory is widely accepted, but it is not free from limitations, and there are certain aspects of the universe which the Big Bang fails to explain. And if you have not seen the part 1 and 2 of the Big Bang explained, we highly recommend you to see them first, as it will help you connect things better. In those parts we have explained the theory around Big Bang and various supporting theories and evidences which have upheld the validity of the Big Bang theory for almost 100 years now. So we highly recommend you to check them first. So let's dive into the topic straight away. There are 3 fundamental limitations with the Big Bang theory, which are known as the horizon problem, the flatness problem, and the magnetic monopoles problem. We now discuss each of them in detail. Number 1. The horizon problem. We know that the universe is incredibly vast, and it's expanding. But the studies shows that the universe is also remarkably uniform in its properties, like temperature, density and distribution of large-scale structures. This poses a problem because, as per our understanding of how things spread and equalize, the universe shouldn't be so uniform on a large scale. And if we consider 2 phenomenon to spread within universe, that is light and temperature, then there hasn't been enough time for them to spread and create uniformity in all of the universe. Cosmologists are exploring various explanations for the horizon problem, including the concept of cosmic inflation. Cosmic inflation suggests that the universe underwent a rapid expansion in its early stages. This expansion could have smoothed out the temperature and other properties of the universe, solving the horizon problem. The horizon problem is one of the unsolved problems in cosmology. However, it is an important problem to solve, as it could provide us with clues about the early universe and its evolution. Number 2. The flatness problem. According to the Big Bang theory, the universe started from a tiny, extremely dense and hot state and then expanded rapidly. Scientists have observed that the universe appears to be very flat on a large scale and not curved or lumpy or with any other irregularities. The problem is that for the universe to be so flat and smooth, it would require extremely precise initial conditions during the Big Bang. Even the tiniest deviation from perfect flatness at the beginning would have caused the universe to be curved or lumpy as it expanded. This precision in the initial conditions poses a problem because it seems highly unlikely for the universe to have started with such exactness. The curvature, or the deviation in curve of the universe, is determined by its total mass and energy. If the universe has too much mass and energy, it will eventually collapse back in on itself. If the universe has too little mass and energy, it will continue to expand forever. The data shows that the universe is very close to being flat, which means that its total mass and energy are very close to being exactly balanced. This is a very unlikely coincidence, and it is difficult to explain with the Big Bang theory. The Big Bang theory predicts that the universe should be either open or closed, not flat. So, the flatness problem in cosmology is essentially the puzzle of why the universe appears to be so flat and smooth, despite the seemingly unlikely requirement for precise initial conditions. Scientists are still exploring various theories and ideas to explain this mystery. The possible solution to the flatness problem is very much same that is for the horizon problem, that is cosmic inflation theory. Number 3. Magnetic monopoles problem. To understand the problem of magnetic monopoles, let's talk about magnets. We know that all magnets have 2 poles, a north pole and a south pole. When you bring 2 magnets close together, the opposite poles attract each other, while the same poles repel. Now, imagine you break a magnet into 2 pieces. No matter how many times you break it, each piece will always have a north pole and a south pole. This means that you can't have a single piece of a magnet that has only a north pole or only a south pole. The existence of both poles is essential for magnets to exist. So, magnetic monopoles are hypothetical particles that have a single magnetic pole. They would be very different from the ordinary particles that make up the universe. This problem challenges the Big Bang theory, because the Big Bang model predicts that a large number of magnetic monopoles should have been produced in the early universe. These monopoles would have been very heavy and stable, and they would have been scattered throughout the universe. However, magnetic monopoles have never been discovered. This is a problem for the Big Bang model, because it is difficult to explain why they are so rare, if at all they exist. So what is the possible solution? One possible solution to all these three problems is the theory of cosmic inflation. The cosmic inflation projects for inflation as a rapid expansion of the universe that occurred in the very early universe. Inflation would have smoothed out any initial inhomogeneities in the universe, and it would have caused all parts of the universe to be in contact. This would explain why there is so much uniformity and homogeneity in the universe, also why no magnetic monopoles have been discovered. Inflation is a well-supported theory, but it is not without its own problems. One problem is that we still do not know what caused this inflation. Another problem is that inflation predicts that the universe should be much more uniform than it actually is. However, the Big Bang theory remains most widely accepted theory for the origin of the universe till date. We as cosmic citizens can only hope that new discoveries in astronomy will only take us closer to the truth. Let us know your opinion in the comment box. See you in the next video. Thanks for watching. Like and subscribe for more.